Okie dokie. So continuing our look at differential equations, so nobody's surprised that this right here says differential equations. The new word for us in this lesson is what it means to be separable, and that will be plain Jane obvious once we actually define some things. So a differential equation of the form dy dx equals some function of y times some other function of x is called separable. Now, just to be clear, this is some function of y. It is any function with y's and not x's. This is some function with x's and not y's. So there are no y's in this box, there are no x's in this box, and those boxes are multiplied together. A differential equation of that form is called separable. We separate the variables by writing 1 over f of y dy equals g of x dx. And you can sort of imagine what's going on here. This is not actually what's going on here, but you can sort of imagine what's going on up here. The dx and the f of y, and in that way we get all the y stuff to one side, all the x stuff to the other side. That is not exactly what's happening here. There are more sophisticated mathematical processes going on, but this does accomplish the separation. And then we solve by anti-differentiating each side. And if you think about it, you got dy on one side, you got dx on the other side, so integrating both sides does the trick. Separate, integrate, rah, rah, rah. It's the chant that will get us through these two examples. We're going to solve for y. Dy dx is x times y cubed with y equal to 1 when x equal to 1. So you'll notice for these types of questions, there are a couple of things in play. There's a differential equation. There's an initial condition. There's some point that's on the curve we're interested in. Otherwise, we get a family of curves. We want one specific curve. You'll notice this is a function of y. This is a function of x. So we're going to bring the y thing to the y side. We're going to bring the xy thing to the x side. And the way this ends up shaking down, we write 1 over the y function. And then the dx appears on the other side. So now what? So we've done the separating part. This side has only y things, and this side has only xy things. If you don't get this part right, there's no sense going forward. So then what happens? Well, then we integrate on both sides. The right side's a little easier, so we'll just kind of stall for time, and then we'll think about what is this? Well, this is y to the minus 3. Antiderivative of y to the minus 3 is y to the minus 2 over minus 2. Well, what does that mean? Well, I'm trying to get y by itself, so we can do that if we just multiply by negative 2, multiply by negative 2. And then we think about what this means. This is y to the minus 2. That's 1 over y squared. So we want y. Well, that means we have to take a reciprocal, right? Reciprocals on both sides. And then we take a square root. But which which square root? Do we take the positive square root or the negative square root? We need to generate positive y values when x is 1, so it would appear that we use the positive square root, not the negative square root. So then the only question is, what is c? Well, we can figure out what c is because we know that 1, 1 is on the curve. So the y value is 1 when the x value is 1. You can solve this. It's not terribly difficult to do. And you can figure out that c is negative 1. And so once we know that c is negative 1, we know what y is. It's the square root of 1 over, let's see, negative 2 times negative 1, that's 2 minus x squared. This is the function. This function solves this differential equation and passes through that point. This one. Okay? So the process is the same every time. We separate, integrate, and then we look to get y by itself. Once we get y by itself, there's some c value that gets solved for, and there's information that helps us find that c. All right. I will demonstrate with a second example. Solve dy dx equals 2x e to the y plus x squared with y equals 0 when x equals 0. This is particularly problematic because this expression right here has x's and y's together, and we're supposed to be able to box out the xy thing and the y thing. But we remember that this plus means that this is 2x e to the y e to the x squared. And then we can rearrange this like so. Then this is the y thing, this is the xy thing, and those boxes are multiplied together. So we keep the x's together and the y's together, and we can bring this on over, and we can write that. So we have separated the variables. The y's are all on one side, the x's are all on the other side. We can integrate on both sides. Both sides make us a little bit nervous. In fact, you may even want to pause what you're doing and think about what happens next. I will assume that you have paused. The thing on the left is e to the negative y. The thing on the right looks an awful lot like a u sub in the making. What's the antiderivative of e to the negative y? It's e to the negative y, negative in front. What's the derivative over here? Well, this is u, that's du, so this is the integral of e to the u. The integral of e to the u is e to the u plus a constant. So now we're trying to get y by itself. So we'll kick the negative sign over using a mathematically appropriate operation. And then we want to bring the negative y down, and the way to do that is to take a natural log, and then it's not too hard to finish that job. So the question is, what is c? Well, you'll recall that 0, 0 is on the curve. So the y value is 0 when the x value is 0. If the x value is 0, this is e to the 0, that's 1. When is this true? Well, the natural log of a number is 0 if the number is 1. So negative 1 minus c is equal to 1, and so it's not hard at all to figure out I think I've got that. Right. I got that. Sorry, I looked at my notes, and it was all sorts of wrong. C is minus 2. So what does this mean? This means that y is negative natural log of negative e to the x squared minus 2. This function satisfies the differential equation and passes through the point 0, 0. Process is the same. We separate out so that all the y stuff is on one side and all the x stuff is on the other. It's important to remember that those boxes have to be multiplied, not added, multiplied. Then we get a differential equation that we can work with. Integrate both sides, find the value of c. A couple of things for you to consider once you click whatever the opposite of play is. Dy dx is 2xy with y of 0 equal to 3. That is to say, when x is 0, y is 3. And then the coup de grace here, like, whoa, with y of 0 equal to 1. Okay, so those are a couple of things for you to consider. When we show up in class, we have lots to talk about with respect to how to separate differential equations. Looking forward to the conversation. Our time is up.